Hello everybody, this is Mr. Bowen. So today we're going to be looking at the ALEKS topic, factoring a quadratic with leading coefficient greater than 1, problem type 3. So I mentioned previously that there are multiple ways that you can approach these types of factoring problems. So last time I showed you one where you bring this 10 over and move it to the end temporarily. I'm going to show you a different one today just to kind of mix it up and show you different options. But I do notice these numbers are a little bit bigger. Something you want to do regardless of your method is always check for a greatest common factor first. It's going to not only make your numbers smaller, but sometimes it disappears when you try some of these factoring methods, and that's no good. So I'm looking at here, I have 10, 27, 18. Although these are a little bit larger, there is no greatest common factor, so I can proceed like normal. If there was, I would just pull it out and then factor the leftovers and stick it back on at the front at the end. But at this point, I don't need to do that. So I'm going to do a graphic method this time called the box method. So I'm going to draw a 2 by 2 box. So now I'm going to start putting some of these numbers in. So I'm going to put this first term, 10z squared, in the first box. And I'm going to go to the last term and put 18 in my last box. And I'll come back for this middle term in a minute. So what I want to do now, I'm going to leave the z's alone. I don't need them for the time being, but I do need to do 10 times 180, sorry, 10 times 8, which equals 180. Got a little ahead of myself there. And I want factor pairs of 180, and I'm looking for ones that add up to 27. Now, writing out all the factor pairs of 180 is going to be very time consuming. So in the interest of saving time, I'm going to go ahead and work that out, and then I will come back and show you guys what I got. Okay, so that took a little bit, but that's okay. I eventually came up with the factor pair 12 times 15. So 12 times 15 does give you 180, and when you add up 12 and 15, you get that 27. So I have 12 plus 15 is 27. So since that's the factor pair that multiplies to 180 and adds up to 27, I'm going to take those two numbers and plug them in here. Once again, the order does not matter. If you put the 15 here and the 12 here, you're going to get the same answer, just turned around, and that makes no difference. So, but you do need to notice that there was a z squared here. So although I didn't need it over here, I do need to put a single z in back with both of those. Now I'm going to find 4 greatest common factors, one for each row and one for each column. Okay. So looking here, the greatest common factor of 10z squared and 12z is going to be 2z, because they both have a z there. Down here, 15z and 18 comes out to 3. And that's my 2 rows. Now I need my 2 columns going down. So 10z squared and 15z is 5z. And then 12z and 18 is a single 6. There's no z here, so I don't need that. So now my final answer, I'm going to look at the row greatest common factors and the column one. So I have 2z and 3. So that's a positive 3, so it's 2z plus 3. And then down here, 5z, positive 6, so plus 6. And if you multiply those together, you will end up with your original problem.